we're going to be solving equations, but I want to show you another way to look at solving equations. Now, most of you know the traditional way to solve equations, which I'm going to divide the screen here into half, is on the left. But I'm going to show you another cool way to do it. And of course, whichever way you understand is the way I want you to do it. So we are looking for x here. And remember, we want x to be a true sentence. You probably can hear my dog sniffing me in the background. He's sniffing all over the computer. Poppy, go sit down. Good boy. All right. So what we're going to do is we're going to solve this x. Now, most of you probably know that this is the first thing you do. You add 2 to both sides of the equation. Now that's where we're getting the word inverse operations, because the opposite of subtracting is adding. So we're going to undo them. -6 plus 2 is -4. Now the next thing we would do is there's multiplying here. So the inverse of multiplying is dividing. So we would divide by 4. These cross off. We're left with x plus 1 equals -1. The inverse operation of adding 1 is minusing 1. So our answer that would make this statement true is if x were a -2. Now, some people have a hard time solving that. So there's a second way to think of this, and it's over here in this table. What we do is we start with the variable x, and then we list everything that happened to x. So over here, by looking at order of operations, the first thing that happened to x was we added 1 onto it. Then we multiplied it by 4. And the last thing we did to this x, after we added 1 and multiplied it by 4, was we minused 2 from it, and that got us to -6. Now, if we go backwards, and we take -6, and we do the inverse of -2, which is add 2, -6 plus 2 gets us -4. And then we do the inverse of multiplying by 4, we divide by 4, which brings us to -1. And then we do the inverse of adding 1, which is minusing 1, and that brings us to x must have been -2. And look, we get the same answer. All right, so this time, let's do the chart first, and then go see if we can make our traditional algebra solving, as we would call it, work. All right, so over here in the chart, we start with x. So what's the first thing that happened to x here? It was -3. And then it was divided by 2. And then we added 7 onto it, and that got us to 13. Well, now let's work backwards. 13, oops, I should have written a plus here. 13, let's inverse that adding 7, which means we're going to minus 7, which gives us a 6. And instead of dividing by 2, we're going to inverse that and multiply by 2, which gives us 12. And we're going to inverse the -3, in other words, we're going backwards, so we're going to add 3, which means x should be 15. All right, so let's do traditional algebra, something you may have done last year with whoever you had as an algebra teacher. They may have told you to do this, and then you start picking your way towards the x. So the first thing would have been to undo the add 7, so subtract 7 from both sides. We're going to undo this division, so we're going to multiply by 2. And then we're going to undo this minusing 3 by adding 3. And if you're seeing, people, we're doing exactly this table. See how our first step was -7? Well, that's our first step over here, -7. And then see how we multiplied by 2? Well, we multiplied by 2 over here. And then see how we added 3? Well, we added 3 here. So whatever floats your boat. All right, so which way do we want to try first? You know me, I like to play with my pens here. So let's do traditional first. All right, so the first thing I'm going to do is move this 8. -2, x minus 4 was untouched. We just moved that 8 to the other side. So 2 minus 8 is -6. Now we're going to divide by -2. X minus 4 equals 3. And then we're going to add 4. So I'm saying the answer is 7. All right, so let's see what happened to this x. First thing that happens to this x was we minused 4 from it. Then the next thing that happened was we multiplied by a -2. And the last thing we did was we added 8, and that got us to the answer of 2. So let's go backwards. Start with our answer of 2. Add 8. Well, let's undo adding 8 by minusing 8, and that's -6. Yep. Okay, so let's undo multiplying by a -2 by dividing by a -2, and that gets us 3. Awesome. Now let's undo minusing 4 by adding 4, and that gets us 7. So whether you like the chart or the traditional algebra, that will be up to you. Ooh, now they're getting tricky on us, and they're giving us a word problem. 10 less than 5 times a number results in 35. Well, I like that results in 35 because results, we learned before, is a fancy word for equals, and it tells us it equals 35. So now we've got to take this part of the sentence over here and make it into a mathematical phrase. 10 less than 5 times a number. Ooh, there's that tricky less than. That means we're actually taking 10 away from something. We're 10 less than that. Right? If I have $10 less than you, you've got more money than me. So I would take you and subtract 10 from you. All right, so now here we're going to kind of make our own chart. So I started with x, and let's see what happened to x. I multiplied it by 5, I subtracted 10, and that got me to 35. Okay, so let's undo the steps. So I have 35. Instead of minusing 10, I'm going to inverse that operation and add 10 to get 45. And instead of multiplying by 5, I'm going to divide by 5, do the opposite, and so x is 9. If I did traditional algebra, the old traditional tell you to add 10 first, and then to get this x alone here, we undo multiplication by dividing. X is 9. So in class tomorrow, we've got a really big one to do. Okay, see you then.